Okay, has anybody come up with any different areas then from 180 metres squared? Has anybody come up with a bigger area? Matthew?
We got 188 metres squared.
188 metres squared. How did you get 188 metres squared?
Well, from the 10 on the left-hand side, and up from there we did 6.
So you had 6 up here, yep.
And then 18 across.
So 18 across.
And 6 down.
And 6 down, which was using your full 30. Yes. Yes, and then how did you work out the area?
We did 6 times 18, which worked out to be 108.
Okay, so you multiplied the 6 by the 18, you got 108, then what did you do to it?
Added the 80 to get 188.
So you got 188 metres squared. So you're using 6 up and
18
across gives you 188 metres squared. So that gives you a different area, a bigger area, using the same amount of fencing, yeah? Do you think this is the biggest possible area?
No.
How might we work, Jake? How might you work out the biggest possible area? What might you need to do? You guys would need to be quite methodical about it. What could you try?
We've tried 20 up and then 20 diagonally down.
Ah, so what did you try? What shape was that?
It was a...
So you've got a rectangle at the bottom, and then you've got...
triangle.
What shape's this?
A triangle.
What kind of triangle?
A right angle.
A right angle triangle. So you've worked out a different way. Fantastic. What area did you get when you did that?
Well, we haven't quite worked that one out yet.
You haven't quite worked that out. Well, maybe that's something that we could look at then, by not just using the fencing post for rectangles, but using it to make compound shapes involving right angle triangles, because that's something else we've been doing, isn't it? Brilliant, okay. If we just stick to rectangles for now though, the best way I think we're doing it would be to work out quite methodically. So we'd try 1 metre across, 1 metre down there, and we'd have 28 left. Then we'd try 2 metres, 2 metres up there, and we'd have 26 left. Yeah, and you'd need to try all the different possibilities using all of the fencing and see which one gave you the biggest area.
Interesting, Jake's group came up with putting it into a triangle at the top, still using all the fencing. I certainly didn't do that when I was doing the problem, at home. So perhaps that's something where, we're going to extend them, we're leading them on, and we're looking at areas of triangles. So use the same problem maybe, as part of your initial work in the next lesson. Hi Sarah, you all right this morning?
Yes, thank you. Yep.
Well done on last time, it's really good. Before we talk about what you're going to be doing today, let's just cast our minds back to that lesson and think about the sorts of things that cropped up. Are you going to address Jake's solution to that fencing problem, which was quite a good way of looking at it?
Yeah, I think it's really important to, for his peace of mind, that he knows that I've looked at it. Well, we looked at it together, didn't we, to find out. And he wanted to do a right angle triangle with the size of 20 by 20, but we didn't know the bottom. So we had to work out the bottom using...
Right, and we used Pythagoras to do it.
We did, yes.
It's not, we don't have to use Pythagoras with them per se, but I know that you've drawn out the problem to scale for them. We know the bottom area of the fencing because that takes off the 10 metres, so that bottom rectangle stays the same. Then we're looking at that top right angle triangle. So we've got one side is 10. We know what the hypotenuse is so that we can work out what the base is. And you don't have to go in to particular detail for that with them, but it's quite a nice word. They might like to use it, and they may well go, these are good, able mathematicians, so they may well go away and think, oh, I'll have a go at that, which would be really good.